All right, we're going to move on to yet another decision that a manager may face within a business, and that's how to maximize profit given a constrained resource. Well, the first thing you need to understand is what is a constrained resource. Companies are forced to make volume trade-off decisions when they don't have enough capacity to produce all of their products and sales volumes demanded by their customers. In these situations, companies have to trade off, sacrifice the production of some products in favor of ones that hopefully will maximize profits. The reason for this is because we have a bottleneck. If you took a water bottle and you turned it upside down and opened up the cap, the water wouldn't all rush out. It would glug out. It would go glug, 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 glug because of that bottleneck that's slowing down the water. If you take a machete, you cut off that bottleneck, then the water will all whoosh right out. So in the long term, we want to eliminate the bottleneck that we have in our business, but in the short term, we may not be able to do that. So given the situation, given the fact we have a bottleneck, which could be the number of machine hours available isn't sufficient to meet the demand of all of our products. It could be that we don't have enough employees working for us to meet the demand. Whatever that bottleneck is, in the long term, we want to eliminate it. But in the short term, all we're really doing is trying to figure out how to maximize profits given our current situation. So when we have a limited resource, that limited resource is referred to as a constraint. So the machine or process that's limiting the overall output of the company is a bottleneck. We're going to have a constraint or a bottleneck anytime we're unable to meet the demand of our products. So if we can't make enough product to meet demand, it means something is holding us back, something is slowing us down. We have a bottleneck. Fixed costs are usually unaffected in these situations. So the product mix that maximizes the company's total contribution margin should ordinarily be selected. Companies should not necessarily promote those products that have the highest unit contribution margins, however. That's the error that people make, students and managers alike. Rather, we want to maximize the product that gives us the highest contribution margin per unit of our constraint. So we want to make the most out of that constrained resource, get the most bang for our buck, if you will, for the units of constrained resource that we have available. So looking at an example will be the best way to approach this. Ensign Company produces 2 products and selected data is shown below. So we have the selling price per unit less the variable cost per unit, which gives us our contribution margin per unit. Then we have our demand and our contribution margin ratio, which we could have figured out on our own. Remember, is CM over selling price. And then it says the processing time required on machine A1 per unit. Now we're going to learn in a minute, I'm sure, that machine A1 is our constraint. So looking at this, I would initially say, let's make some product ones first because that has the highest contribution margin per unit. However, that may not be the right decision because we don't want to maximize the product with the highest CM per unit. Instead, we want to maximize the product with the highest CM per unit of our constraint. So what you need to do for this is take our CM divided by the units of our constrained resource. So if our constrained resource is the processing time required on machine A1, then we take 24 divided by 1. That gives us $24 in contribution margin a minute versus 15 divided by 0.5, which gives us a contribution margin of 30 per minute. So we can see then that product 2 is actually the one we should focus on because it gives us the highest contribution margin per minute of our constraint. So what we would want to do is make all of product 2, and then if we have any leftover minutes of our machine, that's our constraint, we would make product 1 with those remaining minutes. So let's go through it step by step. Machine A1 is the constrained resource that's being used at 100% of capacity. There's no excess capacity or there is excess capacity on all the other machines, which means A1 is our constraint, our bottleneck. Machine A1 has a capacity of 2,400 minutes per week. And we want to know, should we focus our efforts on product 1 or product 2? Before we get into the details of that, let me go back here and just prove to you that we have a constraint. Product 1 has a demand of 2,000 units and each one takes a minute. So the total amount of time we're going to need to make all of product 1 is 2,000 minutes. Product 2 has a demand of 2,200 and each one takes a half a minute. So we need a total of 1,100 minutes to meet the demand of product 2. 2,000 plus 1,100 is 3,100 minutes. So in order to meet our total demand, we need 3,100 minutes of our machine A1. Machine A1 only has 2,400 minutes, so that proves that we have a constraint. So let's look at a quick check. How many units of each product can be processed through machine A1 in 1 minute? So take a minute, pause the video, and see if you can arrive at this solution. You may want to go back to this slide here where it has the info about how long each one takes. And you know the answer, I hope, is B. Product 1 takes 1 minute per unit, so we can make 1 unit in a minute. Whereas at product 2, because it only takes a half a minute, I can make 2 in 1 minute. What generates more profit for the company, using 1 minute of machine A1 to produce product 1 or 1 minute of machine A1 to produce product 2? Well, take a minute, see what you got. And the answer is product 2 gives us the biggest bang for our buck. Because we know we can only make 1 product per minute for product 1, and product 1 gives us a contribution margin of 24, we get 24 bucks per minute. Because I can make 2 of product 2 in a minute, I get 30. Now, I don't particularly care for this 2-step approach. Remember how I did it? We had the CM per unit, which is product 1 and product 2, which was 24 and 15. And then the minutes per unit, which is our constraint, which was 1 and 0.5. And all I did was divide. So the CM per minute is 24 divided by 1, which is 24. 15 divided by 0.5, which is 30. I find that a lot easier because the goal in all of this is to choose the product that gives us the highest CM per unit of constrained resource, which you'll always figure out by taking the CM per unit divided by the amount of our constrained resource needed per unit. In this case, the number of minutes needed per unit. It's 1 step and I get the same answer, as opposed to the quick check, which basically ran us through 2 steps. First, how many units can I make in a minute? Then, how much contribution margin do I get per minute? So instead of 2 steps, I like to do it in 1. And here it is showing you the way we could arrive at that same answer in 1 step. Ensign should emphasize product 2 because it generates a higher contribution margin per minute of constrained resource relative to the 24 per minute of product 1. So even though product 1 had the highest CM per unit, product 2 is the one I want to make first because it gives me the biggest bang for my constrained resource, in this case, biggest bang per minute. So Ensign should maximize its contribution margin by first producing all of product 2, and then with any remaining capacity, it could produce product 1. So we already figured this out because I get excited. So early on, we figured out the weekly demand for product 2 is 2,200 units. Each one takes a half a minute, so we need a total of 1,100 minutes. We have 2,400 minutes. We already said we're going to make all of product 2, so that's going to leave us with 1,300 minutes left for product 1. Because product 1 takes a minute a unit, it means we can make 1,300 units of product 1. Demand for product 1 was, I believe, 2,000 units, so we're not going to be able to make them all because, again, we have a bottleneck or constraint. But if we want to maximize our profitability, given the fact we have a bottleneck, we're going to make all of the product 2 units, and then we'll make 1,300 of the product 1 units. If we do that, we're going to end up maximizing contribution margin at a total of 64,200. So we're going to get 2,200 times the 15 per unit for product 2, or for product 1, it'll be the 1,300 units at 24 for 31,200. Another way we could have done it is we could have said, well, product 2 needs 1,100 minutes, and we could multiply that by the CM per minute, which remember was 30, and that would arrive at 33,000 for product 2. Product 1, remember we had 1,300 minutes remaining, and then we can multiply that by the CM per minute, which is 24, and that would give us the 31,200. So we can look at it in terms of units times the CM per unit, or the minutes that each one takes times the CM per minute. Note that product 1 CM per unit and CM per minute are the same because it takes 1 minute for each unit. That's the only reason they're the same. My point in doing this is to show you that there's more than one way to arrive at the correct answer. It's really up to you. You have to use some common sense and think it through and determine what makes the most sense to you.